Mic check. My name is Mike, so it is a mic check. Check the mic. Hey, okay, so we're going to get started with this panel on the evolving cloud native threat and looking at that landscape from software supply chain to runtime protection. The panel is going to discuss the understanding of the cloud native threat landscape, trends and examples of recent attacks in the wild, as well as real-world challenges agencies face regarding alert fatigue and identifying and prioritizing remediation when faced with limited resources. We'll also focus on the significant increase in the volume and the sophistication of attacks, and then the techniques that attackers are using and how agencies are combating the evolving threat landscape. What I'm going to do is just going to go down the line and have the individuals introduce themselves, tell you a little bit about their background, and then we'll get into questions. I have some prepared questions. And when we get to a point of through those prepared questions, we have some microphones here for folks in the audience to ask questions. So just starting down to my left, Jeff, if you could introduce yourself, talk about your background and your relevance for being here and that kind of thing.
Yeah, the relevance question is a good one. Still working on that myself personally, but my name is Jeff Day. I'm the platform operations lead at the Army Software Factory. I've also spent time as a product manager at the Enterprise Cloud Management Agency, and then have worked with software teams in a DevOps-like role also in the past. So I've got experience across the cloud landscape and as a DevOps engineer, and now lead a team as a set of teams as a platform operations lead. So hyper-focused over the last few years on platform, and look forward to the conversation here. So I'll pass it to Chris.
Yeah, and let me just say that I actually met Chris in the elevator in person. I think we may have either talked or exchanged emails, but it was just kind of ironic that we met there in the elevator with your family. So.
Yeah, I was trying to keep the kids behaved in front of him. So my name is Chris Hughes. I'm the president and CEO of a company named Acquia. It's a cybersecurity consulting firm. But in addition to that, I also serve as a cyber innovation fellow at CISA, focused on software supply chain security. And I've co-authored a book called Software Transparency that focuses on software supply chain security with the publisher Wiley. But I've been in cyber in the federal space just under 20 years, was active duty Air Force. I've been a Navy civilian with NAVWAR Atlantic, and also worked with GSA on the FedRAMP team.
Yusuf Taksiri. Wait a minute. You don't get to go by without the correct pronunciation of Yusuf's last name. It's Taksadi. The H is silent, and if you don't know how to pronounce it, you can refer to him as Mr. T.
Pity the fool. Anyway, I started my career as an elementary school teacher, and elementary students could not pronounce my name, so they made up Mr. T. Anyway, I am a director within the Office of the Chief Information Security Officer. I work for Aqua Security. We're a cloud-native protection platform. That's the reason I'm here. I've been in cyberspace for about 15 years. After my short career as a teacher, I joined the federal government as an ISSO, worked for multiple agencies before I left for the private sector to help bring cloud solutions to the federal government.
Yeah.
Thank you.
Rob Vietmeyer with the DoD CIO. I am the DoD Chief Software Officer. So I have cloud computing and software modernization within my portfolio, and work very closely with our cybersecurity team on how we do DevSecOps, which is trying to convince them that DevSecOps and CI/CD is not just about cybersecurity or just about development. It also involves them and getting them involved. So that's my cultural challenge that continue to work on. And I think everybody knows you, so we don't need
I'm Aaron Weiss. I'm Managing Director of Technology for Google Public Sector, and I am a recovering CIO. I was formerly the CIO of the Department of the Navy, and previous to that, I have 10 years as an industry CIO in Fortune 500, a couple Fortune 500 companies. So excited to be here and engaged with this amazing panel.
Awesome. Well, as you can see, we've got quite a bit of experience in and just an esteemed panel of folks here. I want to thank Aqua Security for putting this panel together and getting a good group of folks with a lot of experience here. Again, I'll have some questions that I'm going to ask, and then we'll get to a point where we can go to the audience. So for a starter question, supply chain security is supply chain security in a cloud-native environment has become a buzzword or a popular phrase lately. But really, what is it, and why does it matter? Anybody?
I can start. To me, it's very simple. Right? It's about safeguarding process and tools for cloud-native applications. It's about ensuring that they're vulnerability-free, and it matters because it helps protect them against exploits.
I'll just piggyback on that and say from the national defense perspective, we've seen a lot of efforts around NIST 800-171 and CMMC to try to harden the environment of DIB suppliers, but malicious actors have increasingly realized that they can target one software supplier, for example, and have a massive cascading impact across many organizations, including federal agencies and program offices. So it's become kind of the soft underbelly of national security.
Yeah, and I'll second that. So what we're seeing, beyond just 171 and CMMC, which is sort of the external supply chain piece of it, but also internally. So as we make this modernization journey, incorporating cloud, incorporating CI/CD pipelines, incorporating DevSecOps, all this new tooling represents a new set of attack surfaces where traditionally we haven't focused as much on the development side, right? So we accredit things for production, we monitor in production, and so our adversaries are now looking at this large attack surface, right? They're looking at new tools and new capabilities and looking at an environment where we haven't been putting the appropriate protections or attention against. And so they're laser focused, right, on using those weaknesses, using cybersecurity to gain asymmetric advantage as we move forward. And so as we look at how do we then position ourselves, moving forward, this is a very difficult challenge where we're looking at CNAP and other tools. How can you help us make this digital transformation? How do we focus the department, refocus our industry partners that this is a significant issue right now in the department, and we've got to do better and help industry partners help us get there.
Yeah, I think just to add on to that, there's the intersection of multiple threads here that really elevate the topic. When you look at, sort of the emergence of cloud-delivered capability through containerized applications, it's a different architecture, it's a different mentality and approach to delivering capability. And then you look at sort of the emergence of these DevSecOps development pipelines, which are focused on throughput. And if you talk to people who are doing this for capability at the tactical edge, you talk to the ABMSs or the overmatches of the world, this is about throughput of code and deployment of capability. And they're looking to dramatically increase capability to deployment. And so as a way of doing that, it's also incumbent that we change how we think about defense, right? Legacy defense of an application. In a legacy application, we're very boundary focused. As you move to this accelerated high throughput development environment, you need to be able to look at how are we also creating cybersecurity defensive thought process around the development pipeline. If you were not mindful of that, it would be very easy to rapidly pump bad capability, bad code out to the field, right? That's right. The point of it. How fast can you get capability out there? Well, you could really quickly put bad things out there as well. So it's going to require a mindset change.
And I think it also includes knowing and understanding. It's like the food you eat, right? Like you need to know what kind of the quality of food that you're eating. You need to know the quality of the software and third-party dependencies that you're bringing in. That there's traceability from the start through to where you're running in production. And as part of that, while we're talking about these protections, what we're doing in dev environments, how we're tracking what's happening upstream of the dev environments that we're doing development in, is ensuring we're not breaking the developer experience. So working through a platform perspective in order to ensure that as we get these protections in place, the process is repeatable and that it helps to streamline and doesn't put a bunch of blockers in place that makes development of software more difficult.
All right. So now that we, have an understanding of that buzzword from the perspective of our panel and why it matters, let's dig into another question. Supply chain attacks have been of major concern, and can you explain how these attacks work and what steps organizations can take to protect their software supply chain?
I'll give a couple examples. There's many different ways that can occur, but the numbers roughly are around like 742% increase in software supply chain attacks in the last few years. Organizations have been finding that out through studies, and there's multiple vectors that can happen. It can happen from a proprietary software vendor, like your Oktas or your Microsofts, who have a compromise and impact all their tenants and customers. But it also can happen to an open source software dependency like Log4j or others that are being widely used, both in proprietary products as well as internally developed products through Department of Defense software factories, for example. And it can happen, by compromising the development process and pipeline, like we saw with SolarWinds, and passing off, malicious code that gets consumed and updated downstream to users. Or it can happen by pulling in a malicious dependency that they've done, like things like typo squatting, or they've compromised a developer who's contributing to an open source software project and put some kind of malicious backdoor in there. So there's a lot of different ways it can happen. Ultimately, organizations need to put protections in place to mitigate it to the extent possible, and then also respond accordingly and minimize the blast radius. And just a couple of plugs for some resources. In the federal space, we've seen like NIST Secure Software Development Framework, for example, can be a great resource. And we've also seen SALSA, as Jeff joked about, which is supply chain levels for software artifacts. And there's some other great resources out there. It's just a matter of simply getting started with those resources and laying that foundation.
Does anybody else want to?
Yeah, well, so I think that was pretty good coverage of the space, right? So we're looking at attackers that are getting access to open source projects that are then making malicious contributions that then get inherited into downstream processes. You mentioned typo squatting, so if folks don't know how CI/CD pipelines work, right? They tend to be automated by a script, and if a developer checks in code, hopefully they have someone doing the oversight to make sure that that code's been tested and approved before kicking off the rest of it. That it can be a rare process, right? So insider threat there. But those pipeline scripts are open to potential attacks called pipeline poisoning, where you can then tell the pipeline to do something that the pipeline engineers don't know it's doing, like reaching out to other sources. Typo squatting is an easy one because these pipelines will tend to look for, if it's told, hey, to build I need all these components to make the software baseline, it will reach out oftentimes to public repositories to pull those components. If it sees something that looks like, so say you've developed a library, that's your internal library. If it sees something that's named the same in a public repo, these tools aren't smart. It will grab one of those, and that could be an attack, pipeline poisoning attack, or typo squatting. Someone types the library wrong, and so the attackers have positioned malicious code in these public repos that sound the same, look the same, just a little bit off from a perspective, just someone typed wrong, and the tools will grab those and inject it, right? And then you have backdoors, you have control, you have control planes, other things injected right into your software baseline. We're also seeing, beyond those that are sort of very specific, just standard RMF control weaknesses around identity management and access control and implementation of least privilege. If you haven't done those things, then attackers are going in. And while the backdoor is more about, and the typo squatting, pipeline poisoning are more about maintaining integrity of the software and assurance moving forward, we're also seeing attackers go after confidentiality, trying to steal technical data and other things that might, in architectures and code baselines that are captured, and steal that intellectual property or use that to devise other attacks. The mechanisms that we're working with CISA on were mentioned, like in NIST, with the SSDF, Secure Software Development Framework, and now working with what does an attestation look like from the vendor community, that they are attesting to secure development practices, and then all the way to software bill of materials, so SBOMs, and in the Department of Defense, XBOMs, because we want them not just for software, but for hardware and AI models and other things. But from a software bill of materials, looking at how do we capture provenance, how do we leverage frameworks like Salsa and Guac coming out of Google and the open source community for maintaining provenance at very low levels and assurance, and how you sign things and how you share, and managing hashes for assured sharing across software. I think what we're seeing is there are a lot of different frameworks. There is, Safe Code from Microsoft, and also another open source project that they're contributing to. There's a lot of different mechanisms, and it's really confusing right now for someone that's on the department side to figure out, should I be doing Salsa? Should I be doing Safe Code? Should I be doing OWASP models for the security? So part of what we're trying to do from the CIO side is we published more than a year ago some DevSecOps guidance where we identified the set of required and preferred activities for what should be incorporated in a DevSecOps pipeline. We're now re-looking at that given some of these attacks and trying to update our guidance to help people navigate through some of these mechanisms, because it's a complex environment right now.
I don't know, Rob, I just got PTSD. You said RMF, and I was kind of blanked out there for about 2 minutes. But I think saying RMF is proof positive of why this kind of mindset shift, in terms of sort of left of boom, intercepting these kind, these bad code injections into a pipeline are so critical. And it's never going to be addressed through RMF, right? There's no amount of spreadsheets and checklists that are going to overtake the dynamic nature of the problem, I think, that we're trying to solve for.
The technology itself is moving much, much faster than those RMF controls, right? than NIST and those lovely folks over there. I mean, they're doing a great job, but they're not updating guidance and controls fast enough, unfortunately. The other thing I wanted to add is just old-fashioned coders and programmers, and they got used to a traditional sense of DevOps. Getting them to move to a DevSecOps model to ensure that in cloud-native applications, there are several stages where the application could be exploited, then that gets pushed downstream. Just moving from a traditional DevOps model to DevSecOps model, I think will definitely improve those areas and ensures better outcome.
Okay.
So,
go ahead.
Wait, hold on, because we can't just blame the developers on this one, right? Because yes, developers can definitely do a better job of becoming security aware. But so I'll tell you, one of the cultural challenges we have, or that I've been having, is getting the cybersecurity teams to understand that this is important to them as well. Like when I said DevSecOps to them, they go, "That's not us, that's development." And I'm like, no, that's not what this means, right? But that mindset's still there, to the point where if I said CI/CD, right, we do a lot of CI in the department. We don't do a lot of CD. So if CD is continuous delivery, means that every decision to get to yes, to deploy, is in the pipeline. Guess what we always do? We don't do that because we bolt cybersecurity on the end. And when I say DevSecOps or I say CI/CD, the cybersecurity team, the RMF teams go, not us, not listening, that's development. So part of the strategy, so it hasn't come up yet, but continuous authorization, part of the why is at its fundamental base layer really is continuous delivery. But if I said continuous delivery, they didn't pay attention. If I say, no, we're going to change how we do authorizations and we're going to call it continuous authorization, so I'm just renaming CD, but in a way that they think it involves them. So that was the strategy there. So equate CATO with CD, and the sort of automation that comes along with it, but really trying to integrate the cybersecurity team. Now, since we did that, I think we're going on 3 years, and we're just about ready to publish the next set of guidance on there. So it's been a difficult roadmap to try to change culture and process.
Okay, you've redeemed yourself.
Okay, thank you.
Continuous authorization.
Yeah.
Yes. Okay, and so I mean, when we talk about sort of a DevSecOps mindset and how to intercept this, so you're really into the heart of being able to exercise that continuous ATO, right? Because we want to talk about continuous monitoring. That's after it's already deployed.
Right.
This is about moving sort of inside the process fence line.
Yeah, and I think there's two things, right? That we want reciprocity, so we're working a lot right now to standardize how we secure containers in a way that's consistent across the department and capture the body of evidence that went into the security, so that if we have a container library such as Iron Bank, that other AOs can pull those containers and have a high degree of assurance and knowledge of the security posture of each of those containers. And then, as you mentioned, is moving to real-time cybersecurity posture awareness, but not just of the production system, but also of the pipeline itself, right? So you see cultural change that we're talking about here is not just the AOs and the ISMs and SCAs and how they function and getting their involvement in the earlier phases of development, but also the cyber defenders, the CSSPs, right? Yeah. Getting them to be able to monitor behaviors and execute response actions, not just in production, but in the development environments as well, monitoring what's going on. And that's changed from them too, right? That's not a space that they've typically operated in.
Well, I love your Iron Bank example, right?
Yeah.
So we all high-fived each other when we said, hey, Air Force and Navy are going to collaborate and share, on Iron Bank.
Yeah.
But that means that bad things that happen in Iron Bank can easily find their way across an even broader.
Yeah, so we're dominating, but okay, we'll get to some others. But I will say we are working several enhancements with the Iron Bank team, with DISA and some others on the container experts on how we get higher degrees of assurance within those containers themselves, and some industry partners that are working some energy companies and critical infrastructure companies that are facing these same challenges about what does secure software look like from all the different dimensions, and how do you create sort of a standardized heat map of representing risk of a particular software artifact. And then pulling in various sources that are evaluating projects from a contributor perspective and looking at things like, has the source code been shared with other adversarial nations? Do they have actors participating in the projects? How often is the project updated, maintained? How much technical debt's within the project? So beyond just sort of the security aspects of this, right, getting into a more complete picture of is this software reliable?
Yeah, one more thing real quick is he talked about the pipeline security, in addition to the software itself, is another great resource is OWASP, CICD, Top 10 Security Risks is another great resource. And, I just want to make a plug for some commercial things, too, that are doing some things better than maybe some DoD-generated programs. We can't let compliance be a blocker to those innovative commercial solutions.
Yeah.
Okay. All right. Well, real good discussion on that. And I'm going to bring it back down to this end of the table. So I'd like, Chris, I'd like you to take the first stab at this question. And then, Jeff, if you have something that you might want to add to this. But we know that, and anybody else that wants to comment after those two go, we know that the most modern software is comprised of open source software, or OSS. What are some steps that organizations can take to address these OSS risks?
Yeah, I mean, that's a fair point. Like studies show 60 to 80% of modern software code bases are comprised of open source software. And actually, Rob answered that question for me a moment ago. So he talked about, obviously we're looking for known vulnerabilities, known CVEs, but there's that's a lagging indicator of risk. If there's a CVE, we already know there's a risk. There's other leading indicators of risk, like who's contributing to the project. For example, Sonotype study just came out this year showing that only 11% of open source software is actively maintained. There's also the fact that most projects have a high bust factor. So, for example, 25% of all open source software has only one maintainer actively contributing code. 97%, I think it is, only have less than 10 people. So who's contributing to it? Is it actively maintained? Is it kept up to date? There's other studies showing that software just hasn't been updated in 2 to 4 years, the components that people are using. And then organizations are still pulling down known exploited, known compromised, known outdated components, even if there is a more modern version of the library to use, for example. So looking at not just leading indicators, lagging indicators of risk like vulnerabilities, but also looking at who's contributing to it, their national origin, how many people are actively participating in the project, is the project robust and vibrant. There's a saying that under enough eyeballs, all bugs are shallow. Are there enough eyeballs in the project, for example?
Yeah.
All right. Jeff?
Yeah, I think kind of extending on that, right? I think Chris's answer is hits the nail on the head. But one of the factors to this is that all of that work that's done has to be continuously evaluated, right? You can have an open source library that's excellently maintained by excellent people, and then 3 weeks later it can be archived, or right, they can transition. The people who are maintaining it, the contributors can all change, and so part of the kind of the process in that is going to be that continuous evaluation of what your supply chain looks like, including the open source side, and doing so in a way that again, doesn't degrade the flow of work that you're able to deliver through your environment. There's tooling now that's available, open source and commercial, that helps you to evaluate these open source repos, right? And so packaging that into the process so that you naturally, every time you build and package and deploy software, are evaluating these different areas of concern, is what's going to let you continue to deliver at speed while not losing sight of the risk that you're incorporating into your products. So I would advocate or foot stomp what Chris said, like taking into account where it's coming from, who's contributing. These are super important factors. If it's being contributed to or updated regularly, also an important factor depending on the programming language. But then you can also improve the development process, that can be incorporated for every product that you're building, and do it repeatedly and frequently.
I would like to add one small thing. So inventory. You can't secure what you don't know you have. I've reached out to vendors in the past asking for an inventory of open source they use. They don't have one. And they use open source. They've had developers pull libraries, use them. Those developers are no longer there. They are still actively using open source, copyright, copyleft. They don't have a complete list of what's within their environment, which tells me that it's not secure.
Yeah, just a quick note, Rob, and I'll throw it to you, is asset inventory has been a critical control for 20 years. And here we are now just talking about SBOMs and inventorying the open source software we use. It's kind of absurd that it's taken this long to think, hey, we should know what we're using.
Totally agree, right? So, and I will just point out that it's not just open source, right? It's also commercial vendors as well, proprietary vendors. Have issues as well. And I think the interesting thing about the work around the SBOM has been with CISA, we're trying to work a FAR clause implementation requiring SBOM delivery. And we've had several major vendors come forward, and there's been a lot of concern about this stuff. And what they'll tell you behind the scenes, not publicly, is that when they ran the SBOMs for the first time, they were kind of shocked. They didn't understand everything that was in their software baselines, and these are major companies, right? And that they're like, we need to slow roll this a little bit because we need to figure it out for ourselves. We're not sure. We're just for the first time getting real in-depth compositional analysis of the various piece parts, and then starting to do the dependency chains of all the different libraries and all the work that we were just talking about to the bus factor, the foreign contributions, the other risk factors that go into that. And so what we're seeing right now, I think, is across both the open source community and we've been working with Linux and Apache Foundations. I think they're definitely taking proactive action to up the assurance level within the open source. But the commercial vendors are dealing with the same. And we've had commercial vendors that will leave vulnerabilities unaddressed for inappropriately long periods of time, right? And so we're trying to bring pressure on those folks to say, hey, the Defense Department needs you guys to get after these vulnerabilities. They're sitting there too long. And sometimes they're responsive, but in other times they're like, hey, you're a small part of our market and no one else is complaining about this, right? So it's, like Chris was saying, it's amazing that we're here now, that these haven't been known or addressed early on. But it's a massive amount of work. It really is. It's really complex as people try to figure out what is in all their baselines, because it is, as you mentioned, 60 or 70% of a normal software baseline is probably open source components, and there's hundreds or thousands of them, each with their own dependencies as well, right? So it's not an easy challenge.
All right. This next question I'm going to start with Aaron, because he is a recovering CIO. And I want the CIO perspective on this initially. So supply chain security takes on many forms in the U.S. government, from cybersecurity. We mentioned a lot of these already, software, DevSecOps, RMF compliance, ITAR, and many others. At the root of all of these themes is software change control and trust. How can organizations make sense of all of these initiatives, and where should a CIO start?
Yeah, RMF for sure.
Right.
Do RMF.
Turn it over to the CISO, right? It's his problem or hers.
I think for me, in my CIO experience, most of the worst scars that I have, and believe it or not, they're not from my time at the Navy. They're from my time in industry, and the scars that I have are where you watch a company be brought to its knees, and you, the CIO, are the reason that it's happening. And more times than not, the root cause of that was a lack of change control. And it's really easy in these really complex environments that CIOs have to be accountable for small changes to add up over time. And it becomes sort of an unmanageable, unfindable, unboundable problem until it's sort of like just comes apart in your hands. And so the ability to get your arms around change control, whether that's, I'm old enough to know that it was DevOps before it was DevSecOps. But
We had a disagree.
I got it. DevOps, change management, change control, and then it became infrastructure as code, and now we're talking about sort of robust DevSecOps, pipeline change management. I mean, that is the sort of the root of any challenge for any CIO. And so usually, I spend a fair amount of time with new CIOs who are very eager. And that's usually my first advice to them, which is get your arms around your cultural challenges of change management. Nobody likes change management. Nobody likes change control. There's that word control. Hey, I'm a developer. You can't tell me that I can't use my legacy tool. I've used Ultra Edit for 25 years. I'm going to just do that forever. Nobody likes to be able to put their arms around change management, but it's a must-have.
But they spend all their time in C++, a memory unsafe language, and rewriting it in Rust or something else. It ain't going to happen, right? And at the end of the day, we see often with the proprietary companies and others that they rather focus on user capability and I'll absorb technical debt. For so long, the development side of things was sort of this esoteric, someone else's problem, right? Focus on user capabilities. But the world's changing quickly, right? And we are seeing the conversation change, as I mentioned. Maybe we hope it's changing fast enough. But we're seeing last year, 70 plus CVEs a day, new ones a day. We're seeing, last year, 50, 60 plus 0 days emerged. These are happening faster and faster every day. And so it's not only all of the protections that need to be built into the pipeline. It's not only monitoring all of the new telemetry that's coming off of all these different tools, different environments, dealing with Kubernetes and infrastructure as code and cloud APIs. But it's also, how do you pull that whole picture together to understand where should you invest your limited cyber resources in trying to fix this wide set of problems, right? And I think that what we're seeing some of the industry tools now bring us is the ability to deploy AI, deploy models like the MITRE ATT&CK, and to be able to take that entire picture and help turn what has traditionally been a red, always red dashboard for your cyber defenders into something more manageable, right, in terms of how can you prioritize what you should go after first. But it is, I think it does take investment, it takes interest, and a willingness for someone to say, yeah, this is important, we need to get after it.
Yeah, we're talking about, like you mentioned, speed to market. Do I focus on the latest and greatest features, or focus on remediating vulnerabilities while my competitor puts that feature out first? So it's a challenge that the industry is going through, especially younger companies with limited resources. Newer companies, like I said, focused mostly on bringing capabilities out to the market before anybody else does. So it is a challenge. We've started the conversation as an industry, and I'm hoping that it continues to go the right direction. But change management, change control, as a cyber professional, they're the most challenging components that I have to deal with on a daily basis.
And I was just going to add to what these guys talked about, speed to market and velocity. They all used words like throughput and, focusing on feature delivery versus, focusing on vulnerabilities and security tech debt. And I think we're seeing the government play an important role of kind of shifting that market failure of cybersecurity by using their purchasing power via things like, memos from OMB, for example, requiring attestations or requiring SBOMs. And I think it's important that we go that route and the government starts to use that purchasing power to drive these systemic changes around software security, but we can't let it override the need to innovate and keep pace with near-peer adversaries and things like that as well, because cybersecurity is only one risk of many.
Yeah. So not a CIO or a director, but from a more tactical kind of perspective, right? I think yes, getting your arms around change control is critical. You have to have good change control, but as part of that is, I think, a shifting nature in how we perceive change control is important. Right? Most of the things that we've talked about here, DevSecOps, infrastructure as code, the configurations for all of that are stored oftentimes in a Git repo, right, where you have Git history, and you can go and see the provenance of every single change. Right, it's visible change, and there's a value proposition to that visible change to the engineering teams and the cybersecurity people. So I think building on that value proposition to engineers so they adopt that change control process naturally, right? They now know what's changing in their environment. The app teams know what's changing about the apps, and the security teams being aware and understanding of those changes, how to view those changes and monitor those changes is what becomes important and powerful to help improve the adoption. Right? Simple things, the infrastructure as code approach, starting those things from the start and designing your system around some of those modern best practices and concepts can really help enable you as you get off the ground with some of your platform work.
Yeah. All right. So there's a buzzword that is usually said at these type of conferences. I don't think I've heard it yet. And so my question before I go to the audience with question is going to be around this buzzword. Does anybody know what that buzzword is? It's always said at one of these conferences that zero trust. Right.
Oh, you're just trying to get your buzzword.
I thought it was going to be CHO.
Well,
where's Randy?
Zero
Randy
trust. Zero trust is right. Okay, so how are organizations using zero trust architecture with regard to cloud-native applications? Who wants to take that? Chris?
I'll just jump in real quick. There's definitely some great information out there from NIST and 207 and other sources like the Federal Zero Trust Strategy, Defense, DoD Zero Trust Strategy, things like that. But it involves, I think it was Rob who talked about starting with an identity-centric approach, and Aaron talked about the old kind of perimeter castle moat that we used to approach cybersecurity from. But that said, despite all the talk of zero trust, we're up here discussing how we have for a long time been openly using software from strangers on the internet without asking where it came from or what's been done to it. So I think there's a convergence between software supply chain security and zero trust that needs to happen because it's not just the architecture, it's the software, and we're trusting a lot of things inherently right now explicitly without ever asking questions about its origin or its composition or what's been done to it along the way.
Yeah, so much for never trust, always verify, right? We just pull down a library, we don't know where it came from, and plug it into our software. Like Chris said, it's very important that we adopt the idea behind zero trust in the use and the adoption of open source software. Figure out where it came from before adding it to your solution.
Yeah. So we're painting this sort of negative picture, right? It is pretty bad, but I think one of the things that we need to be careful of, we don't want to stop innovation. I mean, one of the first examples I ran into was in the Gulf War, and I forget the general officer, but there was a presentation like this. It was probably an AFCEA, and he was doing the keynote, and he was talking about how great the soldiers were in driving innovation. And there was one Army unit, and they had their Humvee, and they were assigned to monitor the cameras on the perimeter, right? And so in the Humvee, and they'd have to stay up. And while they're waiting one night, the guy started doing a search, and he found there was a guy in Germany who had written an algorithm for detecting movement on video images. And so the guy who wrote it, he was upset that his cat was jumping on the sofa. And so he had written an algorithm that positioned a little his little webcam, and then if the cat jumped on the sofa, some alarm went off. But he had written the software algorithm, so the guys were sitting in the Humvee, and they downloaded that software, right, and put it on the Humvee, and then they could have, if there was any movement, they were immediately alerted, right, so they didn't have to, the focus attention for hours and hours and hours, right? And this was touted as, look how innovative we're being, and I'm going, oh my God, they did what?
It only worked if a cat jumped on the sofa.
Right, the cat jumped on the wall, right? It was like, but so I think where we're seeing the solution being in the Defense Department. So we're seeing that we have the push for the software factories and the platform engineering, because what we're finding is that we can, if we focus the right team to build out these platforms that are hosting these environments, we can build the specialized security, testing, validation, guardrails, bring the new tooling, build the advanced NOC capabilities that can understand the behaviors of Kubernetes and cloud and other things, and can watch for and be more responsive than, say, our traditional defensive cyber operations might be with trying to understand all this new telemetry. And so that's part of the push from the department on the software factory side of things, is trying to get more investment going into building these comprehensive platforms. The challenge is too complex and too difficult for every application to figure it out for themselves. And we are finding that the platforms are reusable around a wide range of different use cases in ways that we were concerned about early on. But it's proven to be that platform engineering side of things has to be part of the solution. And now it's how do we get the current CIOs and acquisition authorities to start moving investment to start building out more of these shared platforms, expanding that capability, and bringing that focused cyber resource in a way that many applications, many systems can inherit the underlying controls and value that can be built in underneath.
Actually, it's great, Mike, that you get to fill out your buzzword bingo card by bringing up your trust. I think in this case, I'm going to be a little bit controversial and say they're different. They're not the same thing. They're related only in the fact that zero trust is really about ongoing defensive capability by stitching together trust of a user, do we trust the application, do we trust the device, do we trust the network? There's these different vectors that come together for zero trust. Talking in this panel about software development, security, and secure pipelines is how do you build an app that is able to be trusted, right? So they're related, they're sort of... there's a pattern match to it. But it would be remiss to classify this as zero trust. That's just an ex-CIO's opinion.
I appreciate that. Somebody betted that I would get zero trust in the discussion.
It was a Randy. Randy Resnick.
So, I had to put it in there. Okay, so audience, yes, sir, go ahead.
Yeah, it's a great panel. Lots of fun to listen to you gentlemen. I'm Dave McDonald. I'm here on island with the Department of the Navy, CIO for the last 16 years up at NICTAM's PAC. So we operate all the fleet communications and some SATCOM gateways. So if you don't mind, I want to sort of tee up a little bit. My colleague here, Christine, said heckle the panel, so I'm not going to heckle you, but I just sort of want to provoke and challenge you a little bit.
Yeah.
So I'll frame it this way. And Rob, you'll resonate with this, I think, quite a bit. So the DoD CIO's continuous ATO concept, it's going on, 3 years old, 4 years old? I forget when the memo came out from Mr. McCown.
Yeah.
It's getting a little long in the tooth.
I'm telling you, yeah.
Right? I don't have the broadest view, but I'd be fairly confident saying that high concept's been out there a while. You'd be hard-pressed to find a particularly complete and sustainable implementation of CATO, of continuous ATO, right? There's a whole heap of stuff to unpack in CATO, Mr. Weiss, as you know, because you framed it as cyber ready for the Navy before leaving. So here's the question, and it's sort of in the form of a proposal I want to get your thoughts on. You connect the dots between the idea of CATO, continuous monitoring, putting the SEC in DevSecOps, putting the SEC in CI/CD, resourcing continuous monitoring, tooling using NIST and CISA zero trust principles, right? So you design the thing right, you tool it and build it for zero trust operations, right? Here's the dot to connect. The DoD has invested about $9 or $10 billion in JWCC. We've got this enterprise cloud thing. And Aaron, your comments about having a rigorous governance and change management model that sort of allows CI/CD to do what it's supposed to do, but creates a gatekeeper function for making sure that we're sort of doing it smartly. So the proposal is, why not JWCC as kind of a CATO as a service sort of assurance, a gatekeeper function, right? If you force all of our applications providers into the DoD cloud infrastructure, you don't get in until you're built and sustainable for CATO. So it's a wicked problem. It's world hunger. Rob, how do we do that?
No, I think that that's a part of what we're trying to achieve, right? So I think the JWCC itself is primarily an ordering vehicle with the four vendors bringing forward their capabilities, and what we do through DISA is issue a provisional authorization and then put those packages within EMAS. So anything that's within the vendor's catalog that's available through JWCC is coming along automatically with the provisional authorization package in EMAS. And so if you're building your applications on top of that, you can automatically inherit through EMAS those controls. I think to get to this full vision, as we start to build defense platforms and enterprise services and CI/CD pipelines on top of that, we need to follow that same model, right? So that those services are coming along with the appropriate certifications and body of evidence and accreditations, right? Assessments that's readily accessible to another party, a relying party, to pull that in and to build off of it. So it's definitely where we're going. CATO has taken far longer than I had hoped. We did turn the challenge over to the MILDEPs a little bit. We said, hey, here's our general framework. Come tell us how you're achieving these things. The Army jumped on we thought the Air Force would be first. They still haven't got us their package in the 2 years or 3 years, whatever it's been. The Army was first. Navy followed, and we have assessed now 3 of the 4 MILDEPs on their, and we think we have a good framework to go back to the rest of the department and say, hey, here's what this looks like. We've seen evidence. Here's how this works. So stand by, and I'll apologize for our cybersecurity team delaying that process a little longer than I would have hoped. Or maybe I'll blame the MILDEPs for not getting their packages in earlier.
All right.
I'm going to just go on record and say I think that this pipeline security that we're talking about and your ability to deliver secure code ought to be one of the prerequisites for obtaining a continuous ATO, right? Because this is about how you can maintain cybersecurity on an ongoing basis. So we're very focused today in the DoD on continuous monitoring, but I think this pipeline security is sort of the close relation and the key dependency of being able to deliver that.
Yeah, I think so. Real quick, right? Like, I think one of the challenges here is you can't get two cyber people in a room and have them interpret CATO the same way, right? Like the tooling alone, the aspect, what like we talk about these pipelines, right? And depending on who you talk to, what's in that pipeline, the requirements that have to go into that CATO pipeline are going to change. It's going to change between the Army, the Navy, the Air Force, Marine Corps. And then down through those services, it's going to change by the team or the ISO or the ISM that's evaluating if you're meeting those requirements. There is, like, consensus is forming, and continuing to pursue CATO is critically important. Right? I agree with everyone on the panel on that front. I think one of the criticalities is going to be continuing to refine what it means to have a CATO compliant pipeline. And not just in terms of one size fits all, hey, I don't care what your app is, it has to go down this pipeline. It's going to bottleneck a bunch of stuff all at the same time. So having the ability to be flexible, understand that there's different use cases, different architecture software is going to be built on, right? So you have an approach that allows for that flexibility, but that flexibility in and of itself still maintains the consensus across the operations and cybersecurity communities so that everyone's in agreement. Once the product comes out at the other end of that CATO and is being continuously monitored in the operational environment, that it does get to maintain its CATO.
And just real quick, what he's kind of speaking to is risk appetite or risk tolerance, and it's going to look different for every authorizing official. And it's a little bit more complicated than just throw SEC in the pipeline, throw SAS, DAS, secret scanning, IAC scanning, et cetera. You have to get to like what actually is exploitable, what actually poses risk to the mission owner of the system. Rob talked about, 20,000 CVEs in the last year, 17% year-over-year growth. There's 200,000 CVEs. We can't just kick a lengthy spreadsheet to the developers and tell them, hey, fix these 87,000 findings, or you can't go to production. We have to produce context around that. Is it known to be exploited? Is it likely to be exploited? Is it actually reachable in the application? Without that context, we're just dumping noise, and we're not breaking down silos. We're actually building them.
And that context has to be relevant to the holistic environment, right? We can't just say, oh, this binary has a CVE that might be exploitable. You have to continue to ask the question, is it even reachable within a container? Is that container reachable from the platform? Is that platform reachable from a public vector of some kind or an external vector of some kind? Is there anything that's going to block or prevent, like a web application firewall, in between the two? So having a holistic context awareness of that evaluates whether those CVEs are truly severe or if it's something that, hey, we don't really need to worry about this thing, so we can prioritize other security investments or other investments into capabilities. Right? We have to get to that place, and I think do it soon.
Doesn't that make CVSS scores
relevant?
Yeah. All right, so we've got about 6 minutes left. I have two folks that are standing up to ask questions.
Don't let Paul. Paul's going to ask a really tough question.
I'm going to try to get to both of you. So what I'd like to do is just, have one or two people respond to it so that we can get to both of your questions, and then we'll wrap up.
Would love to hear pros and cons of OMB 2316.
I'll jump on that. I don't speak on behalf of CISA, by the way. I may work with them. This is just my personal opinion. We saw NIST 80171 fail miserably because self-attestations, when there's revenue and contracts on the line, people are inclined to give the correct answer. So with OMB 2316 and 2218, we're moving back towards that self-attestation model of, yes, we're doing all the things securely, we're doing SSDF, et cetera. But the dichotomy there is I've been on the FedRAMP team, and it has a third-party assessment model, and we have 300 cloud services in the marketplace for FedRAMP after 10 years of tens of thousands of services that the government could be using. So self-attestation is not foolproof, but third-party assessment can also bog things down too.
Yeah, and then so does FAR rulemaking, right? So it's caught in the regulatory rulemaking under FAR. But yeah, I mean it's a step. It's not perfect, but yeah, I'd rather get 22, 16, 18, and 2316 out there and start moving forward. But yeah, hopefully we get through far.
All right.
I actually need to keep talking, so.
Drag it out to 5 minutes.
I was enjoying the irony of talking about zero trust and then self-attestation. I thought that makes perfect sense. I think that totally aligns. And I'd love to talk with you about CATO afterwards and why I think it's irrelevant in context of ongoing authorizations within the risk management framework, but that's for another time. Only need one. So, Aaron, I disagree with you just a little bit on your context of RMF, but I'll use this as a setup for what will be a question for you guys to answer. I think the challenges with RMF is how we've turned it into a transactional system for security teams that are not invested or embedded with the operational outcomes that systems are trying to achieve, which means the mission and how I manage risk just becomes a checklist because I have no idea how to track it otherwise. Whereas the risk management framework is really just the OODA loop for managing security risk at its intent. Understanding the intent of what we're trying to achieve when it comes to moving at speed, managing risk, and delivering outcomes for the mission. I'll pose this question and hopefully we'll see your answers. Using the definition of DevSecOps as aligning the incentives, cultures, practices, outcomes, initiatives, tools, whatever you might be, of software development teams, cybersecurity professionals with the ability to say yes and the authority, as well as operational teams to actually run capabilities within a mission environment. Understand that definition. What do you think is the least invested from a people as well as kind of a maturity perspective from the DoD of Dev, Sec, and Ops? And what do you think are the ways to start to solve some of those challenges?
Wow, I guess we need another
See,
hour.
I told you that was going to be a tough one.
So now we need the next hour.
So, Paul,
to
I
address
would say, I don't disagree with your assertion that RMF is being inappropriately flogged, right? I think there's nothing wrong with the RMF concept. The problem is it's being used for evil, not for good. And the problem is that it's being used to create a 3-year authorization, a 3-year ATO, one time, and then a program will come back and reassess that capability versus the RMF checklist again in 3 years. And shockingly, it's wildly out of spec at that point. So I'm with you, but it's not being used appropriately. Yeah. So I guess to your question, what's the most important dev? Because there's a lot of other questions in there. That's the least invested.
Growth and maturity.
I'm going to say ops. And I'm happy to buy you a beer and tell you why. Yeah.
Well, so I'll grab a beer with you guys and disagree with the ops side. So I am biased. I think I would poke too a little bit at maybe not a least invested portion. I think there's a lot of investment going in a lot of places. I think the question I would ask is, are we invested in the right things that are incentivizing the right direction, the direction that we want to go? And so I have a lot of dear friends in the cybersecurity community, love them dearly. So this is not necessarily a poke at them specifically or anything like that, but as an example, an easy to go to example here is like when we talk about investing in cybersecurity, what people are we investing in the most frequently? It is people that are most familiar with the RMS process, policy-based, checkbox-based process. And so if we continue to invest in that direction, I would argue that is our least invested place in terms of DevSecOps at this point, because we need people that are invested in establishing the security controls within that flow of work as part of that flow of work in order to rapidly deliver secure software.
Okay.